Hello, welcome everyone. Welcome to yet again another session. This is the lecture number 4, 12th Chemistry Solutions Chapter 2, and this is the problem solving session number 1. And here I discuss some basic problems. The video runs hardly up to 10 minutes, and then you can, if you want the solutions to be noted down, and this is strictly notes what is pertaining to the solutions. And if you want to make a note, you can always pause the video and then make a note. And now let me run through the problems what I have written over here, and then calculate the mass percentage of aspirin C9H8O4 in acetonitrile, which is CH3CN, when 6.5 grams of C9H8O4 is dissolved in 450 grams of CH3CN. CH3CN is nothing but acetonitrile. And what is the weight of solute? That is 6.5 grams, and that's what is given over here. And 6.5 grams is dissolved in 450 grams. Okay, weight of solvent is 450, so mass percentage of C9H8O4 is weight of the solute divided by weight of solute plus weight of solvent multiplied by 100. So mass percentage of aspirin is 6.5 grams divided by 6.5 plus 450 multiplied by 100, and then when you plug in the numbers, you get about 1.424%, and that's the answer for you, and that's rounded off, and this is the numbers what you get, and then you can round it off to this much percentage. Okay, fine. So let's go for the next question. Question number 2. State the main advantage of molality over molarity. Okay, state the main advantage of molality over molarity as the unit of concentration. And this was asked in December 2010-2009 compartment. Or how does the change in temperature influence the value of molarity and molality of a solution? And like this, the question was asked in December 2011 and 2009, and foreign 2011-2009. And the answer goes like this: molality does not change with change in temperature, while molarity decreases with the rise in the temperature as the volume of the solution increases with the rise in temperature. We know that molarity is inversely proportional to the volume, and that's the required answer for us. Okay, so let's move on to the next question. A solution obtained by mixing 300 grams of 25% and 400 grams of 40% solution by mass. Calculate the mass percentage of resulting solution. This is very important question. That's why I have put the 3 stars over here. Please give a practice. So amount of solute present in 300 grams of 25% solution is 300 into 25 divided by 100. So which works out to be 75 grams. And amount of solute. This, how do we arrive to this kind of thing is like this. You know that the mass percentage is given by the weight of the solute divided by total mass multiplied by 100. Na? So from that you have to calculate the weight of the solute which is present. So the 100 comes down, and then the 300 is the total mass of the solution. That multiplies this 25. That's the idea here, and that works out to be 75 grams. I hope you understood what I said. And okay, let me write it. Okay, you can. I hope you can make it. So the idea is like this. So you have like mass percent. I'm just writing this is equal to weight of the solute divided by weight of solute plus weight of solvent multiplied by 100. Right? This is the idea. This mass percentage is already given to you, which is 25. You got to find the numerator, that is the weight of the solute, divided by the weight of the solution is like 300, what is given, and multiplied by 100. And this is the idea. So the weight of the solute is this number. Okay, that's how you calculate. Okay, 300 you could transport to the other side, and then 100 you transport to the other side. So that's it, 25 multiplied by 3. You can cancel these things here itself and then multiply 3 over there, so that you can do anyway. So I hope you understood what I said. And now here let's go and see what next we can do. And So the same amount of solution present in 400 grams of 40% solution is 400 into 40 divided by 100, as simple as that. So that is 160 grams. So the total amount of solute which is present is 160 plus 75, which is 235 grams. And total amount of solution is 300 plus 400, because they mixed 300 grams of solution 1 and 400 grams of solution 2. So which works out to be 700 grams. Okay, so the mass percentage of solute in the resulting solution is 235, what we got, divided by 700, which is 33.5%. And mass percentage of water in the resulting solution is nothing but 100 minus this one, 100 minus the mass percentage of solute. If you subtract, so you get 66.5, and that's the answer for this. And let's see the next question. How many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2 molar HNO3? The concentrated acid is 70% HNO3. That's the catch here. It's not 100% HNO3. That is 70% HNO3. That's another important question we are going to deal right now. So given the molarity of the solution is 2 molar, volume of the solution is 250 ml, the molar mass of HNO3 is 1 plus 14 plus 3 into 16. 1 is for hydrogen, nitrogen is 14, and 16 3 is 48. That's for oxygen, and which works out to be 63 gram mole inverse. Okay, molarity is weight by gram molecular weight multiplied by 1000 divided by VML, and just plug in the I want to know the weight of HNO3, so the molarity multiplied by gram molecular weight into VML divided by 1000. And so you have 2 into 63 into 250 divided by 1000, that is 31.5 grams. So this 31.5 grams represents 100% HNO3. So please understand, but 31.5 grams of HNO3 is for 100% HNO3, but the given acid is only 70% HNO3. So you got to multiply with, you got to understand the required weight should be taken into account for 70%. So you got to multiply with the 31.5 into 100 divided by 70. That works out to be 45 grams if it is 70%. Okay, so 45 grams of 70% HNO3 is required to prepare 250 ml of 2 molar HNO3. So that's the answer for you. And that's one important question. Okay, next one. If the molality of an aqueous solution of cane sugar is 0.445, what is the mole fraction of the cane sugar? This is the question. That's a nice one. Once again, that's a good question. Given the molality of cane sugar solution is 0.445 moles per kg, that means the number of moles of cane sugar present in 1 kg of water happens to be 0.445 moles. And what is the number of moles of cane sugar from this? You can get it as 0.445 moles. And density of water is 1000 kg per meter cube. That means 1 meter cube of water will weigh 1000 kg, or 1 gram per cc is another way of expressing the density of water. And molecular weight of water is 18 gram per mole, and 1 kg of water is about 1000 grams. And this is one important funda which you all have to know. The number of moles of water is for 1 kg of water. If you take, what would be the number of moles of water? That is 1000 by 18, that is 55.5555, and it continues further. So this one you have to remember, that's a very important number, 55.555. That would be number of moles of water for if I take 1 kg of water, that would be the number of moles. And now molarity of water is number of moles of water divided by volume of the water. And this is another important thing, though this is not asked in the question. This is another important thing which you all have to know. What is the molarity of water? Is the number of moles of water divided by volume of the water. So 55.5555 divided by 1 liter, and that's the molarity of the water. Please understand, that's the molarity of the water. And that, I think I forgot to write moles per liter. Okay, that is moles per liter. Okay, so mole liter inverse, that's the unit over here. That's the molarity. Okay, that is a molarity of water. Okay, so this can be also a question, molarity of water. So that's a question which you can all have to remember. Okay, that's the molarity of water. The next part is that. So let us go ahead. So the mole fraction of the cane sugar is the number of moles of cane sugar divided by total number of moles, that which works out to be 0.445 divided by 0.445 plus the number of moles of water is 55.5555, and so which works out to be 0.445 divided by 56, which is 0.0079. So approximately 0.008 is the mole fraction of the cane sugar. So let's move on to the next one. A solution is cooled from 50 degrees centigrade to 30 degrees centigrade. What is your comment about the molarity of the solution? See, the molarity is inversely proportional to the volume. If I cool this, when the temperature is lowered from 50 to 30, the volume of the solution decreases and hence the molarity increases. So that's the idea. And next one, what is the molarity of H2SO4 solution, that is the sulfuric acid solution, which has a density of 1.84 gram per cc at 35 degrees centigrade and contains 98% by weight. So the given H2SO4 is 95% by mass, which means that 98 grams of H2SO4 is present in 100 grams of acid, and the gram molecular weight of H2SO4 works out to be 98 gram mole inverse. So that is the hydrogen is 2 gram per mole, and sulfur is 32 gram per mole, and oxygen is 16 fours are 64, and that's works out to be 98 gram mole inverse. That's the calculation for here. And the molarity is nothing but weight by gram molecular weight in 1000 by VmL, and plug in the numbers, you get this one 98 by 98 into 1000 by VmL. But you don't know what is the volume of the solution, but we can use the density to evaluate that. That's the idea. So the given density of the acid is 1.84 gram per cc, right? So the density is mass by volume. So volume is equal to mass by mass of the solution divided by density of the solution. And VmL is 100 grams divided by 1.84 gram per cc. So 100 by 1.84 ml. That's the ml. 1 centimeter cube is nothing but 1 cc or 1 ml. This equation you all have to. The next one is that molarity is weight by gram molecular weight in 1000 by VmL. So the volume of solution is 100, and then 1.84 is 100 by 1.84 is there, no? So you can topple this here, volume of the solution, and 98 by 98. So it works out to be 18.4 moles per liter. That's nothing but 18.4 molar. Okay, molarity is 18.4 molar or 18.4 moles per liter. Moles per liter is nothing but molar. And the next one is here. Calculate the mass of urea, NH2CO NH2, that's the formula of urea, required in making 2.5 kg of 0.25 molal aqueous solution. So molality is the number of moles per kg of solution. That's the idea. So solution is 0.25 molal and moles of urea is 0.25 mole. So that's the idea. So per kg of solvent, mass of the solvent is 1 kg. So that is 1000 grams. That is a solvent, and molarity of NH2CO NH2 that works out to be 60 gram per mole. Please work it out. So 0.25 moles of urea is 0.25 mole multiplied by 60 gram per moles of that works out to be 15 grams. So this many moles is 0.25 moles of urea is 0.25 moles. Number of moles multiplied by gram molecular weight. If you multiply, you will get how much amount of mass of that substance is present within the solution. So total mass of the solution is about the mass of the solvent plus mass of the solute. So that works out to be 1.015 kg. Thus 1.015 kg of solution contains urea of 15 grams, and the rest is the 1 kg. Rest of 1 kg is the mass of the solvent. Okay, 2.5 kg of solution will require a urea about 15 divided by this one, 15 by, so that gives the weight by this is the weight fractions which you can calculate. So 15 divided by 1.015 multiplied by 2.5 kg. So that, based on that, you get 37 grams. Okay, so it's like you can have 15 grams in this much. So like this you can make out. I think I'll just explain this. Maybe you are a little bit confused. So I'll just plug the things here. So that you have 15 grams that is present in 1.015 kg. Okay, 15 grams is present in this, and now you need about 2.5 kg, right? 2.5 kg. So you know how much you need. So X is what you had to calculate. You can use the cross multiplication method to do this. Okay, right? So it's X happens to be from this X into, like this you can do 1.015. That happens to be 15 into 2.5. You can do like this. Okay, so that's the calculation here. So X I need, X is 15 into 2.5 divided by 1.0, okay, 1.015. So that's the idea. So that's the required amount of urea we need. So that works out to be about 37 grams. Okay, now let's see the next question. So let's go for the next question. So I hope you understood this clearly, and then let's move on to the next. What is a molality? Okay, what is a molality of urea solution in which 0.0100 grams of urea NH2CO and H2 is added to 0.3 decimeter cube? That in decimeter cube is nothing but liters of water at STP. So mass of the urea is 0.01 grams, and molar mass of urea you can calculate for NH2CO NH2 this much. So this is 60 gram mole inverse, and the moles of urea is the weight of urea divided by gram molecular weight. So this much is one. Water at STP is 0.3 decimeter cube, that is 0.3 kg. As the density of water is 1 gram per cc, you can say 1 kg per decimeter cube. Okay, so that 1 liter of water will weigh about 1 kg. That's the idea here. And the molality is number of moles of solute divided by mass of the solvent in kg, and 0.010 divided by 60 into 0.3, and then that works out to be 5.55 into 10 power minus 4 molal. So that is the idea here. And the next one, the next question is: a sample of drinking water was found to be severely contaminated with chloroform. The level of contamination was about 15 ppm by mass. Express this in mass percent and determine the molality of chloroform in water sample. Okay, so the percentage of mass is 15 by 10 power 6 into 100. So that is 1.5 in 10 power minus 3%. So 15 grams of CaCl3 in 10 power 6 grams of solution. That's the workout what we have. And the mass of the solvent is 10 power 6 grams. And the molar mass of CaCl3 is 12 is for carbon, 1 is for hydrogen, and 35.5 is for the chlorine, and you get 119.5 gram mole inverse. Okay, so molality is mass of CaCl3 divided by molar mass of CaCl3 divided by mass of water in kg. That is the mass of solvent. So here 15 by 119.5 divided by 10 power 6, that's multiplied by 1000. So 1.25 into 10 power minus 4 molal. So that's it guys. That's the end of the video. And thank you all. Thanks for watching.